In this video, we're going to cover SQL functions. And for the most part, SQL functions are split up into two major groups. One's called aggregate functions, and the other one's called scalar functions. And the best way to distinguish between the two is, does the function change the number of rows returned? If the answer is no, then it's a scalar function. Scalar functions are usually formatting functions or some type of function like concatenate. We're going to go through a whole list of them in this video. Average, though, when you get an average of people's ages, it doesn't matter whether you have 2 people in the group you're averaging or you have 2 million people in the group you're averaging, you get back 1 row. So if it changes the number of rows returned, it's classified as an aggregate function. If it changes just the format, but it doesn't change the number of rows returned, perhaps it adds or modifies an existing column, then it's just called a scalar function. One thing I want to bring up in these videos is these presentations are done in PowerPoint. And if you see these slanted lines here, Microsoft likes to switch these. They're not single quotes. Single quotes would be straight up and down. If they're off to the side like that, they are considered apostrophes or they slant right or slant left. So if you are copying and pasting these, you may need to retype them in just as regular single quotes. All right, but moving on with functions. I've put aside a couple of functions here to run. And I've put them into a few pages with a few different categories. So the first one I want to talk about is functions that modify strings. And currently these are scalar functions. String functions include functions like uCase, where I pass an argument or a parameter as of last name here. I alias it as upper last name, and I'm selecting from users just the first 10 of them. You can see everything is uppercase. And if there's a uCase, there will of course be an LCase. So that'll lower everything. Mid is a string function. You may have heard it as substring. It's the same thing. What this means is take middle name, start at the first character, and clip off 1 character. So essentially when I do that, I'm just clipping off the middle initial, A. However, I could change this and say get the second character and get me 3 characters. In which case you'll see here NGE is second character 3 long. And you can do that for any type of string chopping or cutting a part of a string apart. Another string function is concatenate, where I'm passing it the first name, a space, and last name. And what we end up getting is their full name. Colt Trinks, Abel Rowing, and so on and so forth. One thing to note about functions is you are able to nest them. So over here, I'm taking the middle name, I'm getting the mid of the first character, first string, 1 character long, and then on that I'm saying get the lowercase of whatever that returns. So you can nest functions, and now I'm getting all the lowercase first initials. These are the most common functions I use on strings. There is also functions I use on numbers, something like round, where, let's see right here, this is actually retail price. And you see here I had a retail price of $24.99. It rounds up to 25, and perhaps something like $3.50 rounds up to 4, but let's see. I don't have any examples that round down except for the 0 cost. But that basically does a round. The other thing we can do is, and I apologize, I'm changing the column name here, you can round to a decimal place. So instead of rounding to the whole dollar now, we can round to the 10 cent. There's another function here called ceiling. Ceiling always rounds up, which means if I had $9 and 0.0000001, that actually rounds up to 10. So you'll see in here, all of these are going to round up upwards, except 20.00 goes down to 20. There's also another one called floor, and floor basically just drops the decimal place. So even 24.99 drops to 24. These are going to be useful in doing some math calculations, perhaps not so much in retail, but maybe in scientific or other computations. Besides that, there are other functions for dates. And let's see here. That's the numeric. Again, these are all scalar. And date functions, if you select now, I don't have a table after here, and you probably haven't seen this before. Now is a function that returns the current date and time of your system. So we're filming today on 4/27/2006. We can also go ahead and select from tables like orders and use like date format to format the date. So it doesn't always have to look year, month, day, hour, minute, second. We can format it to look like October 27, 2013, 12:00 a.m. Or a more common format I like to use is just month, day, year. Regardless, these formats are available online if you need to Google them, but you can format your date format to any format. Date diff is another date function I like. It returns the number of days between two dates. So if I pass it between now and order date, what I end up with is the number of days that have passed since the order date. And here you see there's 913 days between now and 10/27/13. Again, this can also be used with nested other functions. So here I'm going to give the date diff between now and the order date. And although that gives us the days, that's really not that helpful. No one ever says, oh, I'm 913 days old, or something like that. So what I'll do is I'll divide it by 365, and you can do math equations inside of your select, which will bring it to year. But then we're going to go ahead and just drop the decimal place and apply a floor to it. So now if I run it, that's between 2 and 3 years old. This is between 3 and 4 years old, and so on and so forth. It goes ahead and just gives us an, not so much an average, but a rounded time in years as opposed to the days old. Now all of these have been scalar functions because none of them change the number of rows returned. However, the next group is going to be called aggregates. Aggregates provide more of a summary view, a high-mile view. The database is also extremely efficient at doing these aggregates. So we can go over to here, and I can say, let's select count star from orders. Count star just gives us the number of rows returned, all rows. We've done this before. 19,054 orders have been placed. However, if I say count and a column name, that's the count where that column name is not known. It looks like all our orders have shipped. These two technically get return different numbers if there are shipping dates that are null. Nulls are not counted when you do a count like this. Next one I want to talk about is category. Distinct. Distinct returns the unique values of a column. So over here, I'm saying let's select the distinct item category name. I'm just going to alias it as category. From item category, let's take a look at that table. Here I have comics, cards, games, merchandise. Well, they are kind of unique to begin with. So if I run that, I'll get those unique categories. But where this can be really helpful is remember cable raw data. Remember how these columns, we wanted to get the unique values from genre. So perhaps what I can do is say, let's select distinct genre from cable raw data. And now what I should see, helps if I spell it right. is an alphabetical list here of action, adventure, horror, family, sports, all the way down to sci-fi. Because we use the distinct function, we're not seeing duplicates like are in the table. The distinct removes duplicates. So here we're just going to get that. Something like select distinct gender from users. Well, all our users are male or female. There's no one else in there. Even though we have 175,000 users, we get 2 choices back. So because it modifies the number of rows getting returned, again, this is going to be an aggregate function. So, a couple of other ones. Average is abbreviated as AVG, so this is going to get the average retail price for all items. So my average price is $14.83, with a little more decimal places there. Sum is going to be the sum of all the columns. So if I took all of my items from the item table, and I have many, and I just summed up this column, all these prices, what I end up with is $359,231.09. Min, what is the cheapest item I have? I believe that's going to be 0. Max is what is the max item I have? Most expensive. And I have something in there for $1,199.95. Now, sometimes we want to go and dig a little deeper. And here's what I mean. What if, instead of just getting the average retail price for every item, I wanted to split it up by that item category? Meaning, I wanted to know what is my average price for all videos? And what is my average price for all comics? What's my average price for all cards? So we're going to group them by this item category name. Well, here's what we can do. I'm going to go ahead and select that item category ID to start off with. And then I'm still going to get that average retail price. But just to be sure, I'm also going to get the count and the sum of those retail prices. Just so we can do a little math to make sure that the average is computing correctly. And I'm going to select it from the item table. And I'm going to make sure that the retail price is greater than 0. I'm going to throw out the freebies. And here's the new one. I'm going to say group by item category ID. What this is going to do here is list for each one of those item categories the average, the count, and the retail price. So here, if we took the count of 13,088 and divided it into 147,135.74, we would end up that your average price is $11.24. I'll go ahead and actually do it up here as well. If I was to take this average item price, let's do it a simpler example, and just said group by item category ID. C-A-T-E. Okay. One thing to note is if you ever group by a column, it should also be up here in the select. So now if I run that, here's those item categories, and here's the average price. You can see for number 2, I have nothing in there. These are all promotional items. So the group by command groups aggregate values. Only use a group by with an aggregate function. I never want to see something like this. This returns meaningless data. Will it even run? Well, it's returning the categories, but this just happens to be the first retail price it comes into. It meets C's. You always want to use a group by with a aggregate function. Okay, I have another example here. And this time I'm going a little further. I'm going to say that I want to select the order ID from the orders table. But I also want to know how much each order is for. So when you go to Amazon or you place an order online, and you order 10 items, there's going to be a sum, a total on that. We can go ahead and use that sum command to multiply the quantity times the retail price to get that value. So what I need to do though is I need the order ID, which is right now in that orders table. I need the quantity, which is in that order item table, and I need that retail price, which is in the item table. So I need to join all of these three tables together in order to have all of these three columns accessible. Now, I don't just want to go ahead and get the sum for everything I've sold. I want to split it up by order item, so I know each individual item how much it is. So if I do a group by orders.orderID, what I end up with now is for order 1, if I took all of their items times the quantity times the retail price and summed it just for that item, just for that order, it's $218. And this is the subtotal for order ID 2 and 3 and 4. So if you notice, it did it really quick, 12.3 milliseconds, it did 19,000. The database is extremely efficient at these aggregate functions. So if you can do these computations directly in the database as opposed to pulling them out in another language. Let's see, going here through the slides. Here's a visual example where I said we needed the order ID, the quantity, and the retail price. This is a slightly different, older image where it says item price. That was changed to retail price. But you could see here that we needed the order ID, we needed the quantity, and we needed the retail price or item price here. So we needed to join all three tables. You could look at the ER diagram for that, or you can just go ahead and go in here and say, well, let's look at item. I need that retail price. Let's look at, what is it, item, order item. Well, if I want the quantity, I need to join this table. And the same thing for orders. If I wanted to join it with the user stuff or maybe the order date, I need this table as well. So the important thing for this lesson is that there are two main categories of functions. One's called scalar and one's called aggregate. And in aggregate functions, we need to go ahead and make sure, or you need to understand the group by. And the group by just splits the aggregate results into groups.